Exercise 9, question number 1. A cliff diver jumped from a point 20 meter above 28 meter. Modeling the diver as a particle freely under the gravity with the initial velocity 0, find the time taken. So the person dived from here, from the cliff. This his initial velocity u is 0. So u is 0 ms minus 1, and we'll consider this direction is positive, and a is 9.8 meter per second to this direction, u also, and s also will take that 28 meter. So we need to find the v equal u plus at, v square equal u square plus 2as, s equal ut plus half at square, and I can use this one. U is 0 and I know a, and I can know s, then I can find t. So that is the best fit. S equal ut plus half at square to this direction. 28 equal u is 0 times t plus half 9.8 times t square. So 28 equal 4.9 t square, because this is 0. So t square equal 28 divided by 4.9. So t equal plus or minus 2.4. So t has to be positive, hence t equal 2.4 ms minus 1. The next one is we need to find the v when it's when he hits the water velocity. So I can use this equation. U is 0 ms minus 1, a is 9.8 ms minus 2, and yes, that's all I need. V equal u plus at to downs. V equals 0 plus 9.8 times t is, we found out, 2.4. So that is 23.52 ms minus 1. This has to be 10. To get a more accurate answer, I'd like to suggest that instead of this one 2.4 value, so this is a rounded value, because this is the exact value, this is the rounded value. If you put 2.4, there may be few decimals error. So we rather better to write 0.9.8 0 plus 9.8 times, instead of t, this one, square root 28 over 4.9. So this is 23.426. So basically 23.43 or 23.4 to 3 significance figure. This is much, so this is 0.52. This is not accurate with this number. So this is the most accurate one. 23.42 meter per second for 3SF. Question number 2. The particle is projected vertically upwards with a speed 20 meter from a point of the ground. Find the time of the flight. So this is the ground. So it was projected like this, and then it will come back like this. The projected speed is 20 meter per second, and we'll take this side is positive. So we need to find the time of the flight. So S equal 20, not S, U, ms minus 1. To this direction, A is minus 9.8 ms minus 2, and you need to find the time for whole journey, the displacement. So S is 0. We can use this equation because for this one we need V, which we don't know, but we know that displacement is 0 when it's come and up to the same place. S equal ut plus half dt square. So this is 0 displacement because the ball is still, after whole flight, the ball still in the same place. Now u value is 20 times t, or 20t plus half times minus 9.8 t square. So this is going to be 20t minus 4.9 t square. So I'll bring everything to here. 20t equals 0. I'll take t out as a factor. 4.9 minus 20, 4.9 t equals 0. T equals 0, or t equal 20 divided by 4.9. This figure should be 4.081 ms minus 1, basically 4.1 seconds to 2SF. Question number 3. A ball thrown vertically downward from the top of a tower with the speed 8. It reaches ground 1.6. Find the height of the tower. So this is the tower. So a ball throw from here. So initial speed is 18 ms minus 1. We'll take this side is positive. So u equal 18 ms minus 1 to this direction. So A is 9.8 ms minus 2, T is 1.6 second, and we need to find the distance. So again S equal ut, all the figures align to S equal ut. So S equal u is 18, T is 1.6 times half 4.9 is equal ut plus half at square, half times 4.9 plus 1.6 square. So this value This is 9.8, 1.18 times 1.6 plus 4.9 times 1.6 square. So that is 41,344 meters. Question number 4. A pebble is catapulted vertically upward with the 24. So pebble is catapulted to this direction, 24 ms minus 1. And when it reaches to the top, we know that v is going to be 0 ms minus 1. And the gradient, the greatest height above the point of the projection reached by. So we want to find the greatest height. At greatest height, the velocity is 0. So u equal, will take this direction is positive. U is 24 ms minus 1 and v equals 0, and s we need to find. A is minus 9.8 ms minus 2 for this direction. So s equal ut plus no, we don't have any t's here, so this is the best fit. V square equal u square plus 2a is v square is 24 square plus 2 times minus 9.8 times s, and v square is 0. So 2 times 9.8 times s equal 24 square is equal 24 square divided by 2 times 9.8. So 29.38 approximated the answer for meter. Now the next question is part B, the time taken to reach this height. We can use this one. V equal u plus 80. Then we need time, so u plus 80 equal v. So 80 equal v minus u, or t equal v minus u over a. V is 0. That is s is we found out this value 24 square. I don't want to put that this value, this is not less accurate, but I will put this s. So s is, I'm sorry, so u is this one 24 and e is minus 9.8. No, that's fine. Minus 24 divided by minus 9.8. So t value is 2.44, approximately 2.44 seconds. So the direction we put v equal u plus 80 to this direction. So it has to be this direction because I use a minus value for this one. So we can both the way we want. Question number 5. The ball is projected upward from a point which 4 meters above. So this is the point, ground level. So projected upward. This is 4 meters. And So okay, we'll mark like this. This is 18 ms minus 1. So we'll take this one as a positive side. From this point. So we need to find 15 meter above. This is 15 meter above the speed ball when it's 15 meter above its point projection. U equal 18 ms minus 1. V equal, okay, we don't know that. S equal 18 meters. A is minus 9.8 ms minus 2, and we need the speed here, so v square equal u square plus 2as, so v u a s, so that is the best one we need. So we need v, so when you look at, you can see that the best fit is v square equal u square plus 2as to upward. So v square equal, that's the one we need, u square 18 square plus 2 times minus 9.8 times 15. V square equal 30. V equal plus or minus 30. So upward is 30 and downward also square root 30. Downwards also from here 30. So this is 5.5 approximately ms minus 1. So we'll stay with the first one, the positive one. So in general, when we regard the size, we can tell that V equal 5.5 ms minus 1. The next question is the speed when the ball hits the ground. So this is fine, still stay like this. So this is, okay, I will rewrite E equal 18 ms minus 1 to this direction. A is minus 9.8 ms minus 1 to this direction, and we need, and S we know that now the displacement from here to here, it is 4 distance for this direction, so it is going to be minus 4 ms minus 1, and we need V. When the ball hits the land, so the initially ball here, now it is here, so the difference is minus 4 to this direction. So best fit is this one, V square equal u square plus 2as to this direction. So V square equal u square, that is going to be 18 square plus 2 times minus 9.8 minus 4. So V square equal 402.4, V equal plus or minus 402.4. That value is 400 is approximately 20 square equal 400 plus or minus 20.05 ms minus 1. So we will pick up the negative. The right answer it will equal minus 24 ms minus 1, because when it hits it is in this direction. The size, the magnitude is this one. The speed the ball hits the ground is 20 ms minus 1. So here also when you take the magnitude it is 5.5. But there are two occasions that this is above 15, is when it's going up and when it is going down. When we disregard the direction, so the magnitude is this one. If I explain a bit further, so assume t square is time, t square is 25. So we have answer to plus or minus two answers, plus or minus 5. We know that the time can't go negative. This is a mathematical answer, but the mathematical answer doesn't work with the reality, because uh, x square equal 225. Sometimes x equal plus or minus 5 is work. X is a distance for both sides from a point. Sorry, x is a displacement. But in practical, for a time, it doesn't work. Likewise, when we get an answer for this one, yeah, there are mathematical answer plus or minus, but we have to drop the positive one because we put the equation in this direction, and we know that practically this is the only possibility. In here, actually there are two options. One is the mathematical answer is two options, and that mathematical also actually valid with this one, because when it goes positive and when it comes down negative, so it is mathematical is value match with the external phenomena. Now in the question also it's referring the word speed. Speed, when you usually we don't need to give a direction or just the magnitude. So we want to consider those scenarios when we answer question. So the speed, so because it is a scalar quantity with which the ball, the speed of the ball when it's above 15 meter, we will give the magnitude answer 5.5. Question number 6. A particle P projected vertically downwards from 80 meter above, from 80 meter above. So particle is projected with the speed 4 ms minus 1. So we need to find the speed v when it hits. So u is 4 ms minus 1 and a is to this direction 9.2 ms minus 2. We need so only 1, 2, 3 unknowns. S8 is 80 meter. Now this is matched with this. So v square equal u square plus 2as. So v square is u square, that is 4 square plus 2 times 9.8 times s is 80 meter. So v square is 1584, that is square root So V is plus or minus 1584. So we will stay with the positive answer 1584 approximately 14. 14 square is going to be 1600. Yeah, approximately 14 ms minus 1. And we will, if we need this value, we will apply this value for the sum instead of 40. Find the time it takes to reach the ground. We can work with v equal u plus at downwards v. So t is v minus u divided by a. So v is 1584 square root minus u is 4 divided by a is 9.8, and the approximate answer is 3.7 second. Question number 7. A particle be project vertically upward from the x point. 5 seconds later, P moving down with 10 ms. The projection speed is given 10 ms minus 1. Sorry, this is not the one. 5 seconds later, this one in this direction 10 ms minus 1. This is after 5 seconds. U equal, we don't know the projection speed. V we have minus 10 ms minus 1 because after 5 seconds it is in this direction. That's why I put negative. And E is 9.8 ms minus 2, negative for this direction. T is 5 seconds scalar 1, no need of direction. So we need to find u, the projection speed. U is the issue. So V equal, yeah, we need to find u. V equal u plus at to upward. Then minus 10 u plus minus 9.8 times t is 5. So u is minus 10 plus 9 point times 5. So this is 39 ms minus 1. So projection is speed 39. And part B, greatest height above xy during this motion. So we can put v square v square plus 2as. So s equal v square minus u square over 2a. We know this is applicable. So now we know u value is 39 and v is 0, and yeah, that's all we need. So this is 39 square minus 0 square minus 39 square, because when it is above the highest at v equals 0, 39 divide by 2 times minus 9.8 minus 39 square minus 2 times 9.8. So this is 78 to 2SF. Sorry, distance is meter. Question number 8. A ball thrown vertically upwards with the speed 21 ms. It hit the ground 4.5 seconds later. Find the height above the ground from the ball was thrown. It means above the ground. It means this is the ground level. It was thrown above the ground, so it will come like this. And the throw-in speed is 21 ms minus 1, and the flight time is 5 seconds, 4.5 seconds. So our answer should be a negative value. So u equal 21 ms minus 1, t equal 4.5 second, and s equal, this we need to find, and a equal minus 9.8 ms minus 2 to this one, s equal ut plus half pt square. So this is the equation. So u is 21 times t is 4.5 minus half times 4.9 times 4.5 square. We will get answer as minus 4.7 approximately. The 4.7 to SF. So this height is 4.7 approximately meters. Height above the ground level is 4.7 meters. Question number 9. A stone thrown vertically upward from a point of 3 meters above the ground with the speed 16. The time of the flight of the stone. This is 3 meters and thrown as usual. So throwing speed is 16 ms minus 1, and that's all we have. Data, the time of the flight. S is going to be minus 3. Usually here we know that u and we need a direction. But by the definition of displacement, we need a starting point as well. So basically this is both, all our vectors, u and v directions, but in here the starting points also required for this vector. For u, v and also a, we consider the direction for this one, direction plus starting point. So u is 16 ms minus 1 to this direction, and a is minus 9.8 to this direction, s is minus 3 to this direction, because this is the s is the displacement and we need the right journey. So SUAT is equal UT plus half a t square is the best fit. So s equal minus 3 equal u is 16t plus half a minus 9.8 t square. So this is minus e 16t minus 4.9 t square. 4.9 t square minus 16t minus 3 equal 0. T equal minus 3 plus or minus b square minus b uh, minus 16. 4 times a is 4.9, c is minus 3 over 2 times a is 4.9. T is the positive answer, you will get 3.4 to 2SF. The next part is the total distance traveled by the stone. So v square equal u square plus 2as to this direction. So s is, the plan is this. So we'll find from this place onwards this height, one side, and then we will double to get up to here plus 3. So we'll consider journey A to B. Journey A to B. So when we consider this one, at the top, the V value is 0. That's the only thing, and we don't need this one now. So V square equal U square plus 2AS, S equal 2A. So S equal 0 minus U square is 16 square minus 2 times 9.8. So this value is going to be 13 and to 3SF. So up 13, downward 30, and plus 3. So total travel distance is 13 times 2 plus 3. 26 plus 3, that is 29 meters. Question number 10. The particle is projected vertically upward with the speed and 24.5 ms minus 1. Find the total time for which is 20 meter or above. So 20 meter or above, the total time. So this is the time we need to find. So assume we are going about T1 and at this point T2, basically we need to find T2 minus. So this is the time it is above the ground. Now we'll apply the values. U equal 21, 24 ms minus 1 upward. A equal upward minus 9.8 ms minus 2. And so these kind of sums you need to learn by doing those sums and familiarizing. So when you use to fill this kind of sums, you know what to do. So A is and is also given 24 meter. Now we need the time. So we'll apply S equal ut plus half at square. Actually, I right to do this way. Oh, no, that's fine. 24 equal U is S is 21. So 21 equal 24.5. 24.5 times t plus half minus 9.8 t square. 24.5 t minus 4.9 t square. 4.9 t square minus 24 pi t plus 21 equal 0. So t equal minus 24.5 plus or minus b square minus 25 point square minus 4 times a times c over 2 times 4.9. So you will get two values. One is 1.1 and other one is 3.9 approximately. So T1 is now 1.1 and T2 is 3.9. So T2 minus T1 is 3 point minus 1.1, basically 2.8 s. So this 2.8 seconds, it was above 20-meter level. Question number 11. The particle is projected upward from O with the speed u. After t second, 2 second, the velocity is given 1/3 u. So I put this point is A. So we'll consider OA journey. So u equal, I'll put u bar equal u ms minus 1, v equal 1/3 u ms minus 1 to upward. I put u bar because both u and u. So, and a equal minus 9.8 ms minus 2. T is given 2 seconds. So v equal u plus at, and all are with u's. We can find one unknown then. So this is v is u. V is 1/3 u, and u bar here. Okay, v equal u bar plus at. This is the equation. U bar is u plus a is minus 9.8 plus minus 9.8 times t. So 9.8 times t equal u minus 1/3 u. T also, actually we know that after 2 seconds, and this is going to be 2/3 u. So u equal 9.8. So this 2 to this 2 cancel out, times 3. 29.42 to SF. Part B, the time from the instant that the particle leave O, the instant the return to O. So basically the flight time they are asking. In that case, this is everything is going to be. So we now the value of u is 29.4, and A is same, and S is going to be 0, and we can work with S equal ut plus half a t square, and s equals 0 to this direction equation. U is 29.4 times t is the one we need, and half a times 4.9 t square, 9.8. So this is going to be 4.9 t square minus 29. T equals 0. T factorize 4.9. T minus 29.4 equals 0. T equals 0 or t equal 29.4 over 4 more minus. This is 6 seconds. So the flight time, flight time is 6 seconds. Question number 12. A ball A thrown vertically downward with 5 ms minus 1 from a top of tower block with 46 meter. Uh, 46 meter. So ball throw downwards. Ball A 5 ms minus 1, and then at the same time ball B thrown vertically upward. So ball B upward 18 ms minus 1, and they collided somewhere. So they meet somewhere. So they travel the same time in terms of time. Time equal t, this time also t. Traveling time same when they collided. And let's say this distance is SA and this distance is SB. This is a standard sum. When you familiarize with this one, this is for we have to consider a ball. Then we'll put the to downward. U equal 5 ms minus 1, A equal 9.8 ms minus 2. So SA is SA will take, and time, distance is SA, time is T. So we'll write S equal UT plus half AT square to downward. So SA equal, U mean 5 times T plus half a times 9.8 T square. So SA equal 5T plus 4.9 T square. So now for particle B, particle B, we are using upwards direction. So this is downward, this equation. That U is, let's say UB. UB, so this is UA. UB is 18 ms minus 1, and A is minus 9.8 ms minus 2. Distance is SB and time is T. So S equal UT plus half AT square to upward, then we will get SB, this distance from here. U is 18T plus half a times minus 9.8 T square. T is same for both because the same time is taken to collided. So SB equal 18t minus 4.9t square. Now we know that we didn't use this data 46. If we don't use the data, then we can't make the sum. That's how the sum is. They don't give extra information usually. So SA plus SB is 46 meters. Yes. Then SE is 5t plus 4.9t square plus SB is 18t minus 4.9t square equal 46. This is cancel out. So this is 1, 2. So this is from 1 and 2. We substitute. This is cancel out and 18. This is 20. 3t equal 46. T equal 46 divided by 23. Equal to seconds. It means the total, yeah, there's no total. So this time is 2 seconds and this time they collided after 2 seconds after thrown. So we need to find the distance of the A and B. We didn't finish the sum. So from 1, SA equal 5t, 5 times 2 plus 4.9 times 2 square. This is 10. This is 4.9 times 4. So this is going to be 29.6 meter. Then the total distance is 46. So SB equal 46 minus 29.6, which is 16.4 meter. Question 13. A ball released from the rest of 10 meter above wooden floor. Each time the ball strikes the floor, it rebounds with 3/4 of the speed which strikes the floor. So that is normal behavior. When we drop a ball, we know that it will go and come back again, come back likewise until it will come station. It is few times bounce up and down. So this one like this, and so I will expand this one. This is the first drop, then bounce like this. So this height is 10 meter and it's assume it is hit with V, then this is going to be bounce back, then it will bounce back with 2/3 of 3/4, 3/4. So 3/4 of V, and then it will hit back again. So we need to find this one. Let's say we will hit with V1, then the next one is go 3/4 of V1. So we need to find this height 1 and height 2. So first of all we need to find this hitting distance. For that one we'll consider S is 10 meter down, U is 0, and A is 9.8 ms minus 1 down, and v square equal u square plus 2as. Then v square is 0 plus 2 times 9.8 times s is 10. So v square equal 196, v equal square root 196, that is going to be 14. So it is hit with 14 ms minus 1, and this is bounced back with 3/3 of 14 now. So we will consider now this journey O, A, B, C, D, E. So AB journey, consider AB journey. So now U equal to upward 3/4 of V, 3/4 of V is 14. So that is going to be 10.5 upward, and V is 0 on the top. V is 0, ms minus 1. S is H1 and A is 9.8. So then V square equal to AS. Then S equal V square minus U square divided by 2A. V square means 0 square minus U square means 10.5 square over 2 times minus 9.8. This S is actually H1 now. So this answer is 5.6 to 2SF. Now, the same thing now. To CD, consider CD journey. CD journey. So V1 equal 3/4 of V by symmetricity. Basically, this is a normal assumption then. If there is no other forces with this regard, if you throw the ball with 10 ms minus 1 upward, and it will bounce back with the 10 ms minus 1 with disregard the r restriction, only the gravitational force. If you throw 10 ms minus 1 upward, and it will come back with 10. So then this V1 is equal to 3 over 4V. So then 3 over 4V is yes, we know that 10.5. We were, no, sorry, 14. So this is 10.5 V1, and we now for this journey, when you consider U is going to be 3/4 of V1, it means 3/4 of 10.5, that is 7.875 ms minus 1. It is moving here, and V is 0. So this is this value is 7.875. This is 10.5 ms minus 1. V is 0, and then S equal H2, and A is going to be minus 9.8 ms minus 2. Now same as this one, S equal V square minus U square 2A. So H2 equals 0 minus U square. So I write here H2 equal V square 0 minus U square 7.8 875 square over minus 2 times a 9.8. So H2 equal 3.2 meter to 2 SF. So first time greatest height is you will get when H1, which is V equals 0 with the first bound. The second time highest you will get V equals 0 for the second bounds. And hope you don't confuse with the symbols. So consider AB journey. This V is refer. So when you consider this equation, this V is refer V equals 0 for this place. But here this V is refer when it is the hitting speed to the flow. So this is for OA journey. So every time we use V and U, so this is standard. Consider journey by journey. So this is for CD journey. Now this we refer, not this one. It is this one because we especially mentioned for consider CD journey. And we represent the last velocity, not the first velocity, usually the second velocity. We'll discuss the next exercise now.